Okay, more L'Hopital rule. So 0 times infinity is not anything we've done before, but it is more work. It's called an indeterminate form. These is 0 over 0, infinity over infinity. These are indeterminate forms. This is yet another one. And I've just been using the phrase do more work when you see them. Okay, we cannot use L'Hopital rule on 0 times infinity. So what we need to do is we're going to put one of the functions into the denominator so I can use L'Hopital rule, right? So I can use L'Hopital rule on these two forms, indeterminate forms. So if I'm looking at this, if I put in infinity, I get e to the negative infinity, that's 0. Put an infinity here, I get infinity. So this is 0 times infinity. This is more work. So I need to put one of them in the denominator, and this e to the negative 3x has got a negative exponent, so it looks like it wants to go in the denominator. Okay, so now let's check to see if it is L'Hopital ready. Put infinity, put in infinity, I get infinity over infinity. It is L'Hopital ready, so let's do it. Derivative of root x, 1/2 x to the negative 1/2. Derivative of e to the 3x is 3e to the 3x. Simplify. I've got negative exponents up here, so let's put it in the denominator. Leave things, let's move the 1/2 and the 1/3 together to be 1/6. Now plug in x going to infinity. I have infinity, and infinity in the denominator. Infinity times infinity is infinity, and so I get 1 over infinity, that's 0. All right, so here I'm going to infinity, so this gives me infinity. 1 over infinity gives me 0. Tangent of 0 is 0. So I have infinity times 0. Okay, so we need to put one of them in the denominator. I want you to think about, before you just put random things in the denominator, I want you to put the easier function in the denominator. So it's much easier to put x into the denominator. So I can't just move it in the denominator as x. I need to keep the same equation, right? I can't change the problem. So if I move x in the denominator as 1 over x, right? If I multiply by the reciprocal, I get back to here. So x goes in the denominator as 1 over x. Now I'm going to check to see if it is L'Hopital ready. If I plug in infinity, I get 1 over infinity is 0. Tangent of 0 is 0. Put infinity down here, 1 over infinity is 0. So I get 0 over 0. It is L'Hopital ready. You want to double check that. So then I'm ready to take the derivative of tangent, that's secant squared, carry the angle along, and then take the derivative of 1 over x, which is negative x to the negative 2. And then take the derivative of 1 over x, that's negative x to the negative 2. So let's just make sure you're really clear on that. Derivative of 1 over x is the same thing as saying derivative of x to the negative 1, so that's negative x to the negative 2. Be careful that you don't say the derivative of 1 over x is ln of x. That's really, really wrong. It's the integral of 1 over x is ln of x, right? Here we're doing L'Hopital's, which is the derivative. So be careful. Every so often that'll sneak in. So derivatives here, look at these things. They cancel. So what am I left with? Just secant squared of 1 over x. Now plug in x equals 0, so I get 1 over infinity, which is 0. Secant squared of 0, it's 1. Okay, so now let's plug in infinity. So 0, I'm sorry, let's plug in 0. Plug in 0, I get 0. Cotangent. Here's an important where you have to know your graph. So this is cotangent graph. So if I'm going towards 0 from the positive side, I'm going up to positive infinity. So this is 0 times infinity. Okay, so I want to put one of them in the denominator. And I'm going to move cotangent to the denominator because that can be rewritten as tangent in the denominator, right? Because cotangent you can think of as 1 over tangent. And so if I put it like this, it is now 0 over 0. So it's L'Hopital ready. Take the derivative of the numerator, 3x squared, the derivative of the denominator, secant squared. Now plug in x equals 0. Plug in x equals 0, I get 0. X equals 0, I get 1. 0 over 1 is just the number 0. Last one here. So now I'm going to negative infinity. So putting in negative infinity and squaring it, that gives me infinity. Putting negative infinity into the e. E to the negative infinity is this, let me just write it, but you're not going to write it, you're going to think it. E to the negative infinity is the same thing as saying this, which is 1 over infinity, so that's 0. So here I have infinity times 0. So one of them needs to go in the denominator. I'm going to choose e and put it as e to the negative x in the denominator. So now if I put in the negative infinity, I get infinity squared, negative infinity squared, that's infinity, e to the negative infinity, which is e to the infinity, so I get infinity over infinity. All right, it is L'Hopital ready with infinity over infinity. Take the derivative of x squared, I get 2x. Take the derivative of e to the negative x with chain rule, it's negative e to the negative x. So then, where did my negative go? It just went away there, didn't it? I guess I lost the negative. So let me put it up here. So now plug in negative infinity. So if I put negative infinity in here, e to the negative of negative infinity, that gives me e to the infinity. That's infinity. So negative 2 over infinity gives me 0. Last one. So limit as x goes to 0 from the positive side, and I need that because if I'm talking ln of x, I can only come in from the positive side. So if I go towards 0 from the positive side of ln, this gives me negative infinity. So I have 1 minus negative infinity, and if I plug in 0, 1 over 0 and in the e gives me infinity, so that gives me infinity. So I have infinity over infinity. So now I'm ready to take L'Hopitals. So the derivative of 1 goes away. The derivative of negative ln of x gives me negative 1 over x. Chain rule to take the derivative here. E to the stuff times the derivative of stuff. Take the time to simplify, right? Multiply by the reciprocal. That gives us an x on the top. Now plug in 0. So I get 0, e to the 1 over 0, that's e to the infinity. 0 over infinity gives me a 0.